Football. Okay, well, thanks for inviting me, and this is a little presentation I've kind of already done for the Fort Wayne Astronomical Society, but I revamped it quite a bit, and I've got some examples. I brought some examples, so if it gets too long, just bug me and I'll speed it up. But anyways, blah, 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 3D printing for amateur astronomers. What's 3D printing? Why use it? What kind of materials? Oh, yeah, you can look that way too, sure. Practical examples at the Fort Wayne Astronomy Society. And okay, is this a mic? Is this on? Yeah. Okay. Examples from other amateurs. Help, I need a what's it. And I think I might have deleted some of that. And simple rules for how you get in the queue and get your stuff printed, and non-astronomical stuff, and then kind of questions. So why use it? Well, number one, it's really good to make a custom part not available. Wait, did I jiggle that? All right, do. There we go. The circle of death from Microsoft. Make a custom part that's not available. Yeah, you can improve an existing part with new features. Get it now, man. Don't wait 3 days at Amazon. Probably the number one thing is complexity is cheap. Like normally in traditional, I'm a long time manufacturing engineer. So when you manufacture something, like you look at a car part, and I was like, well, the design's always got these things on it called features. Like I got 3 holes so I can, mount the motor, right? Great. Then I need places for the hoses to go and this and that and the other thing. And all those other things are kind of features. They're things you need. So every time you build something, it seems pretty simple. Like if you got a plate with 2 dozen holes in it, the guy that's doing the drill press has got to drill 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 20, whatever. But with 3D printing, the extra features cost almost nothing, So you can imagine if the printer's running along and you said, I want a plate with 25 holes, let's imagine we got a metal 3D printer or something. Great. Doesn't matter if it looks like Swiss cheese or not, and so it's kind of interesting. But as the features get more complicated, that's why you don't see people, they don't sell 3D printed parts that are very, very simple, like just a sheet of plastic. But when it's some complicated part, and replacement parts for out of service parts that are broken. What do you do if something's out of service? I don't know. This is just a brief overview of how it works. I'm not going to go into great detail, but you can see in the diagram. But essentially, you got a CAD image, computer-aided design image, and it's sent to the printer. And then the printer goes either in a Cartesian form that's shown here, X, Y, and Z, or the printer I have at the house goes in a kind of a radial direction. It's a little different, but either way, it's got to go in three dimensions, and it just squirts the stuff out like toothpaste. The toothpaste hardens up, and you got a part, right? So consumer grade materials and kind of processing and popularity, the most common is what they call polylactic acid. And it's actually derived from soybeans. So let's go, Indiana, man. This is good. Most of the parts that I have out here are made out of PLA. It's very versatile, very easy. The only big drawback is it's a little weak, and it has some temperature limitations, but unless you're most astronomers are not, cooking their telescopes at 120 degrees Fahrenheit. So it could be a minor problem, possibly in an Arizona observatory, but normally it's not a huge issue. PETG also is the same stuff that they put in like those liter Coke bottles. Okay, that kind of plastic. There's even people that take those bottles and they somehow recycle them into little thin threads and they make their own filament. That's if you want to be super cheap, you could recycle those. And PLA is I don't know, it's polylactic acid, but you normally don't see that like in other than 3D printed stuff. Yeah. Um, it's kind of an organic, and then there's thermoplastic rubber. Uh, for more stiffness, there's carbon fiber filled. For example, some of these parts were made from carbon fiber filled PLA, and PETG and nylon. Some people even call that like a black aluminum because it's very stiff and it's a extremely good engineering grade material. ASA or acrylonitrile styrene. Acrylonitrile is excellent for outdoor use. And I think that might even be in your eyeglass frames, but it's very weatherable. Nylon's a little higher heat than PETG. It's pretty tough. And polycarbonate is probably the highest heat thing I've got on the list. And that's very difficult to process on a consumer machine, although the manufacturers keep up in the game. But it depends if you got a printer that's can fill the bill. That normally I would say you could do PLA, PETG, thermoplastic rubber, carbon filled PLA, and PETG. When you start getting up into nylons and polycarbonates, it needs a lot higher heat cartridge. And in the case of nylon, especially, you have to keep the material dry. So you have to either dry it in an oven and then you have to put it in some kind of special drying box. But this all used to be kind of hard, but now all the machine manufacturers are making it easy because, here we'll sell you, an add-on, right? But, my view is that normally if I don't need to make something out of polycarbonate or nylon, I'm going to make it out of something that, works pretty well. So, okay. This material strength, just a couple words. You can replace a steel or aluminum part, but you got to check to see if the strength is an issue and design around it if that's an issue. A lot of astronomy parts don't require high strength, and we'll see some examples as we go through the astronomy parts. I get my face out of here. Okay, some examples. What do we got here? On the left, we have the hand controller for the Orion. Dell was asking me what mount I have, and this is one of the mounts I have. It's an Orion SEQ5. And the existing holder is over here on the right. It's this plastic job with like a webbing here. Okay. So what's the problem? Well, you put it in there, and then it's sliding up and down, etc. And I don't know, the design wasn't too perfect, so it wasn't always easy to slap the controller in. But on the let's see if I can move this. Okay, it's nothing down here. But on the left is, well, let's go back. On the left is what I replaced it with. I took the original design and I kind of imported it into the CAD by basically measuring it. And then I designed a little clip that goes in there. It kind of like wedges in there. So when you shove the clip in, it just jams it in. It's there. Yeah, it's friction, and it works pretty well. And I made it out of some orange material because I like things that I need to know where they are in the dark to be brighter, like, yeah. And if you bear with me, I can click on this and let's see if this will play, but it's not gonna. Oh, there we go. Where's my? Yeah, that's the original one. Yeah, I'm not seeing volume here. Okay. Yeah. But anyways, you can see like it was loose and this other one is much stiffer. Yeah. And let's see if I'm not at the end of the video. Yeah.
You
So
leave it mounted then, or is it?
yeah, I just leave it. I don't take it off, you know. But you know, one of the things you talk about is like you can always right there. Just pop it in. Yeah. But you know, the interesting thing about making something is that you find out like what the deficiencies in the design are. And it has one deficiency. If you load the tripod in your car and you're not careful, after a lot of time, you can break the the you know the clip or whatever because it's kind of sitting out. So okay, so I'll probably just make it a lot stronger, you know, instead of having. Okay, and then I got a thing about hand controller design. What am I looking at? Okay, wow. Okay, sorry for all the tech stuff. Okay, so this is basically a little. Okay, okay. I don't have my mouse with me, so I'm kind of. Oh, there we go. I can turn it that way. Yeah, yeah, yeah. And then if I. Oh, do you? Yeah, I can probably survive without it, but yeah, basically that's so I didn't model up the whole tripod, just that one little section, and that's kind of what you got. So that's the CAD program I use, which is free for me. So like it works. It's pretty similar to SolidWorks, you know. That's called Onshape. Onshape, Onshape, right? You can sign up for a, I don't know, like a like a free license as long as you're not building anything for commercial use, right? And it's command if you're familiar with SolidWorks, it's fairly easy to use and a lot of printer people like it. This is a solar viewfinder. I think I gave one of these to Kurt a while ago. And this basically, I started off with a viewfinder that looked not this similar, but I just changed the design and I was able to print it up. And oh yeah, here's a video that shows you a lot easier. Okay, wait, there we go. Yeah, I wish you could hear the sound. Sorry. Yeah, so
For other things on the market like this, or you got one that was similar and you unviewed it?
no, really what I saw on the market was there was like a disc, two discs, and one had a hole in it, and that was basically it. And I was like,
You just kind of bullseye it.
yeah, and I thought, well, this is stupid, but the thing is, it's very easy to 3D print because 3D printing likes to have it doesn't usually like to have you to make a bridge over an open space. So if you have a strut that comes to a single point, it can it as it prints, it'll make that it can deal with an angle that's up to even 45 degrees, you know. So it's very easy to 3D print. And I just like the way it rotates around and it gives you the bullseye, you know. So
Stop the whole circus.
yeah, I mean, if you guys want some, you know, I'll, it just fits in a standard holder, man. You know, it's not like a, um, yeah, it's a standard Vixen finder shoe. Yeah. Yeah. And this is a little bit of overkill. This is a Losmandy D plate I made for a friend of mine. And there's some questions you got to ask yourself. Why am I doing this project for a guy that's got his own private observatory? He's got a Tech 140 telescope and he's got an astrophysics mount. And he's worried about spending like $200 on an aluminum plate. So he wants me to 3D print something. I don't know. But, I liked him. So I thought, what the heck, it'd be interesting. So he wanted a Losmandy plate to mount a camera on top of his telescope. So I took a standard plate and the dimensions were on a website. It was probably a Stellar View plate. And let me see. What we did was yeah, this is really too high tech, but basically he was really picky about like, well, how much deflection is that plastic going to have? And I said, well, I don't know. So since I was just recently out of work in industry, I had this Onshape also has links to other finite element programs, which is basically a fancy way of analyzing the deflection. And he wanted a deflection of, I don't know, less than a thousandth of an inch when his camera was on. And when you went on to when you added yeah, we got up to like, oh my God, I don't know if that's 6/10,000ths or 600,000ths, but basically the typical, yeah, that might be a typo, but yeah. But anyways, the point is it probably got a third of the deflection with increasing the thickness a little bit. And
What was the mount for?
this is for mounting some additional hardware on top of his Tech 140 telescope. So he had a telescope and he wanted to put a D plate on top. And then on top of that, mount some other stuff. So you could,
I mean, not.
no, it was,
Be held vertical.
right. It was a camera, kind of like I think it was a digital single lens reflex camera. And he wants to mount that on his telescope, point his telescope at, whatever, and then take a wide field view. So instead of spending 250 on the plate and the hardware, let's 3D print it for $10 because, I'm a retired guy and I thought, well, what the heck. But
Tolerance.
yeah, but I mean, he probably, I don't know if he worked for L3 Harris. He worked for some defense contractor in the area and he was a pretty techie guy. So the camera mount, yeah, this was a $10 materials. And I got versus 60. It's probably more expensive than that, but this is a kind of a knockoff of the Losmandy. Losmandy has a camera mount like this called the DVCM. It goes in two directions, and this is only in one direction. But you can see it has two sections of clamp. I did not bring this, and this is what mounts on that D plate. And so, I modeled the knobs. I'll talk about the knobs in a little bit, but basically I took some of the dimensions and then we thickened up some plates and, he wanted to get less than a thousandth of an inch. So, okay. All right. What do people, oh, and then I made another copy for the Fort Wayne. Oh, it had I didn't take this one out, but Fort Wayne had they have a 16-inch telescope with a derail on top. Only made out of aluminum. They didn't do a 3D printed thing, but I made a camera mount for them. There you can see so you could just put a camera on top of the 16-inch and piggyback whatever you want. So let's see. Okay, now here's the one that I brought, which is, I think this is more neater. This is the standalone. So if you got a camera and you've got a tripod with a Vixen mounting, I built the Vixen mounting shoe into it and a red dot shoe here. So all you do is you just put the whole thing on top of your tripod. So why put the telescope and then the camera on top of the telescope unless you want to have more fun in the middle of the night fumbling around? That's kind of what it comes down to. So And this is another question. This was a new guy that I met, and he had a problem. He didn't have a place he needed a finder with a StarSense, I think a StarSense Explorer unit on the scope. But he had a set of, yeah, he had a set of rings. Um, and um, so I printed a finder shoe that had a new through hole to mount on his rings. But after some thought, I started thinking a dovetail bar would be easier to mount his camera and his guide scope and his finder shoe all at the same time. So basically, I pulled together some things, and that's one of the things with 3D printing is making a one-off thing is you don't have to enlist an entire machine shop to do something. You know, you can sketch it up and figure it out. So basically, I invented this thing I call it the super bar, And here's the super bar. Yeah. So this is a camera, and this T-shaped thing is what I call the super bar. And so you got a receptacle here for a conventional finder scope. And then here, it's another finder scope, but that's the StarSense finder scope. And then there's the bar on the right. And, I think I made another one and I put it on my Stellaview, like on a 102 ED that's here tonight. And it's worked out, So I thought, okay, I don't use the StarSense anymore. I ended up selling the StarSense, so that part's like superfluous. But if I need an extra finder scope or I don't know, a guider or I don't know, you could just put stuff up there. Yeah. So this is a little wordy, but what did I do? I used the Stellaview. I used the ring dimensions. I changed the OD a little bit to fit the bar. This is interesting. 3D printing has kind of got some interesting features. You can do some things mechanically you can't normally do, and you could print like hinges in one piece. Everything's all interlocked. And I was a little bit worried about the strength of the clevis pin. I printed the clevis pin and the hinge pins, and I made them bigger, but my hunch was that they were a little undersized. And then I basically made them bigger, and then I confirmed it with a break test, which involved me like twisting the crap out of it, seeing if I could break it, because normally I'm not going to do that, but and I added the red dot finder, and let's see what it says here. A complete set's about $9. And I think if you did a whole ring set that's pretty good quality with everything, maybe 100, 200 bucks, And I built it out of 100% carbon fiber PLA. Okay, and there you go. That's the same as what you see up front. The only difference is I think my front knob has broken. Oh, that's terrible. So what that means is I got to go back to the printer and just print another one, which is like a couple hours, and that's it, Um, these knobs are not, I didn't really work very hard on designing the knobs, and I'll show you why in a minute. The scope rings. Okay, here, this is what I wanted to show you, the integral hinge. This is very interesting to me, at least, Okay. So if you look, boy, it really stinks we don't have that audio. But look at that. See the hinge. Oh, I can take it off the scope. And then those holes on the side, those are actually tapped holes so that you could put, another, as if you don't have enough hardware already, you put another couple finder shoes on there. No, I let it tap them, I mean, you might have to chase them, but normally if you have it set right, you can just run a screw in and you're done, man. Exactly. That's what I'm saying. You see the operations, it's all in like yeah, there's a lot of stuff in there. But anyway, so you got to, and why I did that, basically I had a clamshell. I didn't have a set of rings for that. So I don't know. I thought that was kind of interesting. Yeah. Yeah, and here's all the FEA stuff. Basically, red's bad, blue's good, green's in the middle type of thing. And it, yeah, it shows you the stresses. And let me see. I don't know if one's before and after. They might be just screen grabs from 59. Yeah, they're just screen grabs from a couple different orientations. And I don't remember what I think around 6,000 PSI is bad, but I basically changed them and, you know, got rid of most of the stresses, and it's kind of confirmed by it. But, I'm not working for L3 Harris on this project. I'm just, yeah. Um, yeah, and here's another finder shoe. I think I got one of those up here. I basically copied an existing finder shoe, put the threads in, and now all I need is a little screw. So there's a finder shoe, and you can put that on any scope. And this happens to be the bracket for the star sense, but any finder scope would fit. Here's some rubber eyepiece covers. There's a little bit of stringing, but they're serviceable. They're flexible. This is a spectroscope extension tube. So we have a guy that's got a spectroscope on that 16-inch, and for some reason he needed a tube that moved the focus or something out 75 millimeters. So I said, okay. So I just drew it up, and I got the thread, and it printed the threads, and then it actually print like you can emboss. So in other words, all this white lettering, when it printed, those are all like basically holes or embossed into the plastic. And then you just take some, I don't know, white paint or silicone or something, stick it in there, but it labels it nice. So it says, spectroscope 70. So then the guy knows what he's got. He's not going to say, oh, that's just a tube, throw that in the garbage, whatever. Yeah. So I kind of like the idea you can ID stuff. And then here's some example. I did a Botnitov mask and a lights mask, and I don't really do a lot of, I'm starting to get into it, but I had big plans, but I'm not totally with the astrophotography game yet. But anyways, the mask is here. I actually cut it out and put a solar filter in there for the eclipse trip in April. And this is a lights mask, so I don't know how good that works, if that's as, good of a flat field as someone would want. So you can't just like, I don't know, just do it during the day or something. It's got to be right. Okay. Well, I made it. I don't know if it's as functional as we all want, but maybe. But anyways, it's kind of interesting. But I like the mask. The mask was easy. There's a lot of mask designs out there. You guys are gonna say. So here's one for the finder on a 16-inch, but the finder is only an 80 millimeter. So there's a mask, right? So I didn't need to do any engineering because I just pulled it off of, a couple of different places on the web, and I just sized it, and I actually calculated the material cost. It was like 15 cents. So you were asking about material cost. Yes, the materials per pound are much more expensive than regular plastic, but when you figure it out, it's not so bad, usually. Let put this bar back up here. Okay, and this is a red dot finder. On the right is a typical thing you get. You get like a screw, right? So I don't know about you guys, but I just hate the screws because I'm putting it on and off my telescope, and I'm not good with a screwdriver in the dark with a dark screw. It just doesn't work for me. So I made these, and I just put the thread in there, which is I don't remember what the thread pattern, but it's, you know, and bing, and you can see it. Um, the plastic, you talk about plastic and material. Obviously, this screw is way weaker than this one, but we're not putting 1,000 pounds on it. However, if you screw them really, really tightly, like I did once or twice, you can break the screw. Okay. But I have really normally don't have a problem, but I've got like extra screws. So I mean, like I could print an extra screw or have a couple spares. And so, you know, that's that's my take on it. Could I get super material that won't crack? Yeah, sure. Is it a pain in the neck to process? Probably. So, that's yeah, it makes the threads. Yeah. Yeah, it prints it, right. Here's something that's a little more mundane. It's a dust cap. Okay. Everybody's losing dust caps. Everybody's losing eye caps. Um, here's the Bogan. I got a manual Altaz mount from Stellar View. My neighbor gave me a Bogan tripod, and I don't know, the head doesn't mount, didn't adapt to the mount. So I made this adapter, which is this little plastic piece. So all I basically had to do is mount it, put some clearance for screw holes, and you know, I I mean, that stuff is really invaluable. And then this is kind of experimental, but I brought it. But basically, I didn't like when you get down to really, and you're fiddling with your mount and you're moving it, manually to get lined up on a star. It works pretty good, but honestly, Stellar View doesn't have a slow motion control on there. The advantage of theirs is you just swing it around and it's got this friction clutch and it works really good. You move each telescope and it stops right where you point it. But they need some so I started looking into planetary gears and I drew up this little gearbox. Um, how's it work? Well, all I got to say is it's under development because uh, I think the one that I brought, I think honestly it would work if you kind of didn't screw it to the plate and you just um, held the base and then just used the 60 to, but anyways, it's like a 60 to 1 reduction. But anyways, this gives you an idea, man, if you got some imagination. And what is this thing? It's a giant gumball machine. No, this is a model of the moon, and the CAD model doesn't show all the peaks and all that stuff, right? But anyhow, I built the base and I got involved in other things, but the top part I've got modeled somewhere, and you can actually download NASA's lunar surface data. And yeah, and there's this cool thing called, let's see, what's it called? It's called lithophane, right? So you got a picture of your loved ones and you want to have them on a lampshade or something, and you can take that photo and it'll like shoot them on there, and it makes the thicknesses different. And when you put a light behind it, it's great for your kids. Like here's dad, or here's my dog, Rover, and that stuff. So anyways, you do that with the ball, right? And you got all the craters. When you turn the lamp on, bing, you see the craters. And so my intent was to put not just the craters, but to put all the landing sites on there. And then um so anyways, but here's something I did. I don't have it anymore, but this is a Ioptron Smarty Q Pro mount, a light duty equatorial mount that kind of sort of works pretty decent most of the time. And I lost one of these battery covers. Okay. So I need to replace it, and also I ended up selling it. So that's kind of even more. And I just took this existing thing and modeled it up with the CAD. And then I don't have a picture of the printed. This might even be the printed one. I can't tell. They're pretty close. But the cool thing is like, so when I was talking about the beginning, you can modify stuff that you need to make work better. if you got a spare part, I mean, where do you get a Smarty Cube Pro battery cover? I mean, what the heck? I mean, I don't, like it's Chinese companies, they're not real good with the catalogs, right? So, here's some discs, coasters. Yeah, I made a coaster set for Fort Wayne. We could make some for Warsaw. You got a logo, so you just, bang it in there, Yeah.
And how do you really take that, you think you can tell them something, or?
Well, the easiest thing for me is some sort of CAD file, but you probably don't have that. So what you got to do is you got to take a JPEG, and then you got to bring it in, and you got to ask some outside software to try to digitize it into a CAD thing. Sometimes that leads to some difficulties, so you might end up like just blowing it up on the screen and like manually digitizing. In other words, you're just pointing and clicking a whole bunch of dots around the outline. And yeah, it's a pain, but it's like after 30 minutes, you're done. Yeah. I mean, it's not like it doesn't need to be done to like, a millionth of an inch precision. Yeah. And sometimes the CAD, the automatic programs they have that, there's probably expensive ones that aren't free, but that's not my, but sometimes they don't trace the outlines exactly, or they give you too many dots and it's like a zoo, so you're probably better off just hand digitizing it, but yeah, it's doable. It's not a big deal, you yeah, and I mentioned something earlier about easy to see in the dark. The coaster, you can see it in the dark because it's got lighting, white writing. Huh? No, 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 no. No, they're not painted. No, you just start it out in black and then it goes up to the top, and when it's done, then I switch the filament out, and it's like I don't know, like the cake lady putting the decoration on. Yeah. And then the ones I brought you, there's two styles. One I got a little more sophisticated, and actually I got the lettering and whatnot, pushed in, because I left holes for the lettering, and then the machine does its thing, and then it goes back down and squirts the icing in the holes, basically, so, so there you go. Knobs. This is like one of my favorite subjects because you always need knobs, right? All these knobs are derived from McMaster Carr, which is a big machinery supply company in Chicago, knobs, and they have a catalog, which is really cool. I use these on the camera mount, but the easy thing is you basically just buy a socket head cap screw, and you put it in your drill press, and you turn the drill press on, and you heat it with your heat gun for about 70 seconds, I'm sorry. And then it's hot enough, and then you just use the press and push it right in. And
solid, so otherwise your knobs are solid core, and that
yeah,
steel gets pressed in.
well, they're right where the head goes. They're hollow, but there's a little bit of an interference,
Enough,
Yeah, enough that it goes in, right. And this knob that broke off was probably, processed incorrectly by me, because normally the heads don't come off, but if you don't heat them long enough, they're not gonna get enough plastic around. But that detail on what's the dimensions? Well, the wonderful world of CAD, McMaster Carr says, here's a CAD model of our knob, and it's like complete in every detail. So it's like they're giving me license to steal or something. Oh, I should take that out of the video. All right. No, but yeah, you don't need to scale it or anything. You can. So yeah. So like if you look at like let me see where am I? This knob here is not represented up here, but this one's up there. One of these bar knobs is up there. And this is just a screenshot from McMaster, but they have plastic knobs that are all designed to be, heat a bolt and put it in, And I think they even have some that, you put a bolt in and you put a screw in and that kind of thing. So, I mean, they got you covered. Yeah. Oh, we get to click on this and see McMaster Power car. Yay! There you go. What size? What do you want? I mean, yeah, yeah. I mean, they got the whole thing here. What's you know? Yeah. So it's amazing what's out there. Oh yeah. And if you wanted to use the lettering, hey, we could have special lettering on the outside. Pretty cool. Yeah. I don't know. I love McMaster car, man. They're like one of my favorites. Meteor crater in Arizona. Yeah, there's a little plaque here. It's small, but I modeled it from Google. Yeah, Google Earth. Google Earth. So there's a trick that they use to model things in the real world. It's like a technique called photogrammetry, which is you take dozens or maybe 100 pictures of something from all different angles, right? In the old days, people sat together and they said, okay, um, I took a picture this way, that table, and then this way, and that corner there is the same as that, and you marked them all, and it was complicated. But now the software just does it all magic. So you just run your camera around. So what you do is you go into Google Earth and you tell Google Earth to like whatever I'm looking at, whether it's the Grand Canyon or Mount Everest or the meteor crater, just start spinning that thing, right? And it starts spinning it around. And then you tell the computer to record like a little movie. Okay, so it records a little movie. And then you shoot that into this software and out comes the 3D model. And then you can print it. That's crazy. I mean, you know, so parts from other amateurs. Um, another ring set with inserted thread inserts, and I printed my own in there. Some binoculars, covers or caps. Yeah, that's pretty. Yeah. I think this is a camera holder. Um, and I found this. I think they might have an update, but here's cloudy nights. And there's just a lot of people that, okay, have stuff that's out here. And there's many, yeah. I mean, there's just, let's see if I can, oh yeah, this was kind of cool. He's got some way of hooking, that's his smartphone holder, I think. So it gives you an idea when you guys are talking about that software. Yeah. And right. Let's see. Oh, he's an adapter for his camera and his bayonet, apparently. Pretty, it's kind of mundane stuff, but yeah, right. Finder scope bracket. Yeah. There's the rings. This guy's really going to town. I'm not sure what all he's got, but he's got the idea of the knobs for sure. What is this? Event cover, cooling fans without removing the cover. Okay. Oh, he's showing it printing on his machine. Oh, this is something. We're getting into mechanical stuff here. Oh, he's got some kind of an automated platform or yeah, for his dog. That's what it is. Yeah. Yeah. Anyways, I don't know. I tend to like a little bit some of the simpler stuff, even though let me see. What's on 41, I wonder. I don't know. A fossil. I don't know, but you guys can, man. I've even seen a whole model of a, like, I don't know, it was a 6 or an 8 inch Dob. Somebody's got a kit, you could put one together for, with 3D parts for, I don't know, $60, $80, whatever. Okay. Oh, yeah. And then this is probably the one that I was looking at. You can also go into this site called GrabCAD and Thingiverse. And yeah, this is a Dob. Okay. So you guys got any questions, or you could look at some of the examples if you like. So, okay.
So, wise, you mentioned there's a limit to how big of an object.
Right, but they have, obviously you can buy one that'll print like a pickup truck or something, but
I know a few.
yeah, yeah, yeah. Oh, the average envelope is somewhere around, I don't know, probably 10 inch cube, if you think about it. Um, the printer that I have been using is an FL Sun, and it's like I forgot it's got like 3 arms, and it moves in a kind of a very interesting fashion, and it's a little different than the Cartesian style. But anyways, so it has it's almost like a circle that's 10.5 inch around and about 360, which is about 14 inches high. So it's got a pretty big, but anything you can fit in there it could do. But what about something bigger, like you're talking about your 12 inch, right? Okay, so a lot of times you can do tricky tricks in CAD, like you could split those into 2 or 3 parts. Some of the printing software now even has uh, easy ways to take a big part and you just say, I don't know how to figure this out mechanically. I just need to split it in halves or quarters. And it actually puts like dovetail joints in there, like automatically. Yeah. Yeah. So you just point to where you want the joint. I think one of them does like a lap and one does a dovetail. It's up to you. And they've, you know, it's amazing. So I don't think that's a big deal. I mean, what I'm picturing for your Botnitov, you could split it in three and have like 3 ring sections and 3 intersections. That's the actual mask, and you just put them. The easiest way would you basically have a groove on the inside that holds the three. Essentially, like you took a piece of pizza and you got 3 slices of a pizza. You know what I'm saying? Okay, so you put that inside the ring, and you got 3 ring sections, and to keep it put together, you just use a little glue or something. I mean, it's not going to be subject to, you know, yeah, not too much stress, right? Most of the time they're pretty good. I mean, sometimes there's a little cleanup, but not too bad. If you have overhangs, like let's see how to picture this. Okay, suppose you picture a cube and you hollow out the inside. Okay, so I got a square base and I got 4 pieces to come up and then something over the top. Now that's what you call like a bridge, because essentially I'm trying to span from A to B, right? So the way the um, the kind of printer that I've got works is it squirts stuff on. So if it tried to squirt stuff in empty space, you know, I mean, try squirting toothpaste in the middle of the air, and it's what happens, right? There's a few tricks. Sometimes they can bridge 6 or more inches, because as they're squirting out the plastic's actually hardening in the air. So they can do tricks like they can go from here to here across an empty space, and all you end up with some rough, uneven surface under, because first couple of layers are just like a little bit of strings, and then it builds up on, so there's tricks. But the other way to get around it is they do what's called support, which is it prints a kind of a lattice work that breaks away. So you can basically, and on top of that, then they print the real stuff, and then you just pull out the junk, right? So you can print just about anything you can imagine using any of those kind of techniques, you know. So
I would think then,
oh, yeah. Well, typically layer heights are maybe, I don't know, a quarter, a millimeter, 2/10, which is about 8 to 10 thousandths of an inch, right? If you want to print something really fine, like some of the threads I've printed where I had to use a 1/10 of a millimeter, which is 4 thousandths of an inch. So fine threads, you can do fine threads. They're not as good as a machine, but they're apparently good enough, you know. So I mean, it's a pretty versatile technique. I mean, you do, you know, the width of the lines is, I don't know, 15 or 20 thousandths of an inch.
yeah, like,
Yeah, you can replace nozzles, and you can do something and go to very small nozzles.
maybe down.
Well, they're in there. I can show, but there's layers, but the layers are basically bonded together, you know. I mean, they're kind of melted on top of each other. If the layers are coming apart, there's probably an issue with the printing wasn't set up right in the first place. And I got a few issues, but you know, yeah.
With your moon, lunar moon, did you do that in 2 halves?
I haven't made it yet, so
Oh, okay.
I haven't.
Well, I wondered.
But there's
Can
two
you-
ways.
can you
Yeah,
still get the-
yeah, I can print it from the bottom up in one piece. If the bottom is not, if it's got a hole about that big, which is exactly what I got, because then it'll come up like this. And I think I did like a test piece, but when it gets up to the very top, then it starts to have some.
Build it as, would you build it one?
Well, that's what I was
150.
thinking, but after I started reconsidering what I was doing, I decided I'm gonna split it in half.
Would it require some lattice on the outside? You have to
No,
structure it up
that-
and the relief is on the.
No, it'll be fine, you know. And if I have to put some support underneath, I can put some support. But basically, the idea of having two halves is that if there's any cleanup right around the top, where you're almost going horizontal, then you could clean it up manually and then just glue them together or something, you know.
Well, like I said, if you don't like it, you just change your parameter and hit print.
Yeah, it just, and then
For another
another,
79 cents anyway.
yeah, see if did I have anything else in this? No. Oh, thanks for listening. There you go. Ah. Okay,
What's the cost benefit? How many parts do you have to print out for the cost of the printer?
okay. That's a good one. I do have something on that. I don't know if I can pull this up, but typically the materials are like, I don't know.
You're saying.
Okay, I have a log, and this is can you see? Oh, you can see it. Great. Okay. All right. So this is a log from way back in 21, and like everything I printed out, you know, the CAD says, it's so many grams, blah, 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 you know. And then I figured out the cost and then the material price. So if we go up to, I don't know, here's a knurled, no. What are we looking for? Let's look for a knob, man. Okay, there's a knob for a camera mount. Okay, that was for the knob cost me 40 cents in material. And if you figure the cost of the machine as if it's making $1 or $2 an hour, $1.50 an hour, it's like the 240, but you're really, I don't know, you buy the machine and all you're doing is shoving a little bit of electricity into it, so.
Yeah.
If I was a commercial business, that's what I would charge, right? But this was a 15-gram knob, right? So 15 grams translated to like 40 cents. So, let me see if I got spools. Ah, here, so, okay. So, for example, let's see if I got it. Oh, yeah, here is a half of a kilogram, and it was about a pound, was like, this was carbon filled PLA, so it's more expensive. It was like $64. Normally, this was a whole kilogram. That's a 2.2 pounds for $24. That's probably more typical of what I use all the time. So that's the PLA. So that's about, yeah, that's the cheaper stuff. That's kind of my universal go-to most of the time. So you're talking what, maybe $8 or $9 a pound.
You use that as a sample first, as a test, you don't want to test.
You can, but I'm not too worried about that. I just go for it, because then if I find out there's a problem, I'm not gonna find it out in the cheaper PLA.
Nice program.
Yeah.
Yeah.
Well, thank you for that,
So
right.
it's a run-of-the-mill printer.
Well, now they're pretty inexpensive. I think you probably can get a decent home printer for $250 or something like that, you know? I mean, I think this Bamboo Labs came out with a super duper printer that I think it was almost as much as 12 inches on a side in terms of what you could fit into it. Anything that's 12 as a dimension under 12 inches, go, you know. Yeah, and it's all super automated, and and I think they came out and they were charging about $900, and all these people were saying, man, this is the greatest since sliced bread. And it was a very nice print. Now it's like $500 because it's next year. That's last year's product. Right? So I don't know. I kind of like last year's product a lot because it gives it a year. It's like buying a car that comes out with all the greatest stuff, and then you find out, I worked in the automotive industry for a long time, and I don't know, there's parts, Malibu headlamps, that I could tell you about parts that we said, don't do that. And it went in, and then they would bring in cars into warranty claim with little plastic parts that were falling off inside the headlamp. And it was because the designer didn't listen, and we told them that wasn't manufacturable, but then we fixed it. So buy it the next year.
Telling you this is what I want. Here's the black box. You design it.
Right. Yeah.